In this video, we're going to visualize some networks with NETDRAW and run some basic network analyses. So in UCINet, click the NETDRAW button, which brings up the NETDRAW window. Then File, Open, UCI Dataset Network, and select, let's start with the asymmetrical network. And if you push the lightning bolt, it just relays out the network with an algorithm to spread them apart. Now, if we have a look at Feather and Galton, you can just drag them across, and you can see that the link between Feather and Galton is asymmetrical in this network. It's only in one direction. If we just close that network down and push open again, and this time we'll choose the symmetrical version, and now you can see that the link between Feather and Galton is represented by a two-way arrow. So just rearrange that a couple of times. Now on the right we have the relationships that are loaded. There's only one relationship, and then if you click nodes you'll see all of the dolphins listed. Now if you turn off Galton and all of its links will disappear, and you can turn off a few others. Then to make them reappear, select node, inactive nodes, and change status to active and push OK, and you'll notice that they've all come back. Now if you remember, this was a weighted network, so some of the links, like the one between Feather and Galton, actually occurred multiple times, so that's weighted with a 6. If we go back to the relationships box, then down here, presently we're showing all of the links with a value greater than 0, so everybody's showing up. If we push greater than 1 to increase that, you now see there's very few links actually with greater than 1, and if we continue on up, then after you get to 5, you'll only find that link between Feather and Galton. And to return that, just turn that back to 0. Now this is one big connected network. If we want to analyze for nodes that, if they were removed from the network, would separate it into several smaller components, then we go to Analysis, Blocks and Cut Points. And this shows you that there are 7 dolphins in blue that, if removed, would break the network into smaller subcomponents. If you now select the Nodes tab, and then the down arrow next to ID, you'll see that there are cut points in here, which is, if we just turn off the other, you'll just have those nodes that are cut points in blue. Then if we take out the cut points, you get an idea of who they were connecting and how they break the network into subcomponents if they're removed. So if we took trigger out of the network, you would see that cross and 5 would be then isolated. And the same goes for jet, linking these two. Next, to calculate one of the most important network metrics, the degree of each node, head to the Analysis menu, Centrality Measures, and then in here you have quite a few: closeness, degree, betweenness. Make sure you select the undirected version because we're working with an undirected network, and you can choose one of these. We'll choose degree to set the size of your nodes by. Degree is essentially how many other nodes that each node is connected to. So in this network context, how many other dolphins each dolphin has been in contact with. So if you look at Jet's got 1, 2, 3, 4, 5, 6, 7, 8, 9 alters, or other dolphins that it's been in contact with. Jet has a degree of 9. Again, these have been added as new node attributes. So if you select degree, you can actually invert the selection with this button and turn on only those nodes with a degree of 9. Or you can select some numbers such as 10 and find only those nodes, or in this case those dolphins, that have got more than 10 connections with them. If you select A for all again, all of the dolphins, all of the nodes come back. We can also select attributes for the links, the ties. So in this case, we would like to set the width based on how many times the dolphins are in contact with each other. So head to the properties menu, lines, size, and tie strength. Uncheck change arrowhead sizes to match. You can set the minimum and maximum size range, select the relationship, and select apply. Now if we look at our old friends Feather and Galton, you'll see that they have quite a large wide line between them, representing the weighting there of 6. And we'll just relay out the network again. Then looking at some other relationships, you can look at betweenness, and we may invert the selection and just look at a few of the nodes that have the most betweenness in the network, or you can select all. So to have a look at those nodes that have the highest betweenness, we might decide to change their size based on their betweenness. So you select attribute based, select the attribute betweenness, and apply. And if we just relay out the network, you can see that SN100 and B-Scratch, many of the paths through the network pass through these two. If we chose another relationship, closeness, this shows that dolphins that are very close to all the other dolphins have small numbers, whereas those that are a long way from all of the others have a much larger closeness number.